Okay, so we have seen the notion of the rank of a matrix. So a matrix in general does not have to be a square matrix. So it can be a rectangular matrix. We have seen how the notion of a determinant is applicable to a square matrix. So in this lecture, we will see how it's possible to work out the rank of a matrix, an arbitrary matrix, square matrix, or rectangular matrix, doesn't matter, using determinants, right? So we have already seen how one can get the rank of a matrix using row reduction, but it's also possible to evaluate this in terms of using determinants of certain submatrices, right? So that's the subject of this lecture. Okay, so the rank of a matrix is simply given by the order of the largest square submatrix with a non-zero determinant, right? So it's best explained with the help of an example, right? So you consider some matrix. I have a matrix with 3 rows and 4 columns here, right? And I want to find out what its rank is, right? Of course, I can do row reduction. You know the drill, how to go about finding the rank of this matrix. Now there is another way to find this, which is find all submatrices. How do you find submatrices, right? So submatrices are a submatrix is obtained from a given matrix by deleting some rows or some columns. So in this case, for example, if I were to delete the first column, I am left with this submatrix. So in fact, the first column itself is a submatrix, right? But we are interested in square submatrices. So we would be interested in this matrix, for example. There are only two 3 by 3 submatrices, right? So if you're given a 3 by 4 matrix, right? So then the maximum rank that this can have is 3. So which is the minimum of the 2 dimensions of a matrix, right? This is something that you can convince yourself if you think about it for a moment, and it's also evident from here, right? So we have said that the rank of a matrix is the order of the largest square submatrix with a non-zero determinant. So there are only two 3 by 3 submatrices here. So let me highlight these two 3 by 3 matrices. So if I'm able to find either of these to have a determinant which is non-zero, then I can immediately conclude that the original matrix has rank 3, right? But on the other hand, if I find that both of these determinants are 0, then I will look for 2 by 2 matrices. Is there a single 2 by 2 matrix whose determinant is non-zero? If that exists, then the overall matrix will then have the rank 2 and so on. So let's do this. So you may want to pause your video and ask yourself, what are the determinants of these two matrices? Can you work this out without doing any elaborate calculation, right? So we can quickly convince ourselves, in fact, that both of these matrices have determinant 0, right? Why is that? So if I look at the first row of this first matrix and the second row, if I take this and multiply by -2, okay, so I wanted to arrange this in such a way that the second row is a factor of this. So if I do 1 into -2, this is okay. So I want to change something here, right? So let me redo this. So I will recast this matrix as -2 here and -4. So I want to do this because I want to arrange it in such a way that the second row is a factor of the first row. So that just to illustrate how this is doesn't have a rank 3, right? So let me also be careful about 2 -2 and -4. So if I do -1 times -2, I get this, -2 I get this, -2 I get this, right? So there was a minus sign which was missing, right? So I had thought that I had arranged these two rows in such a way that second row is a multiple of the first row, right? So if you, right, so given that this is the matrix that I'm interested in, then indeed you can quickly see that both these determinants are 0. So then I go to one order lower. So I will look at all submatrices, square submatrices of size 2 by 2, right? But I don't actually have to look at all of these. If I can find even one such 2 by 2 matrix whose determinant is non-zero, then I am done, because this matrix is then going to have rank 2, and that's the case here, right? So let me find for you, I have given here 2. Okay, so there is minus 2, so this is a minus 2, so minus 6. So indeed, both these. So how did I get this first submatrix? So here I have, pulled out these submatrices just to show you what can classify as a submatrix, right? I have deleted the second row entirely. Then I have deleted the third column and the fourth column. So I'm left with 1 minus 1, 2 minus 1. This is an acceptable submatrix. And likewise, in the second example, I have constructed this by deleting the first column, second column, and the first row. So I have minus 2, minus 4, 1, 3. Both of these are 2 by 2 submatrices whose determinant is non-zero. But actually, you just need to find one such a submatrix whose determinant is non-zero, and then you're done, right? So it tells you that this matrix, overall matrix, has rank 2. But I mean, just to eliminate the possibility of 3 by 3 matrix, so there you have to look at all possibilities, right? If you are able to show that all the possible 3 by 3 matrices have determinant 0, then for sure the rank of your matrix is going to be less than 3. And then if you want to establish that it's not even a rank 2 matrix, or lower than rank 2, then again you have to go over all the possible 2 by 2 submatrices. But if you're able to find even one such submatrix to be non-zero, then you can immediately conclude that it's a matrix of rank 2, right? So this is a short lecture describing this technique of extracting the rank of a matrix using determinants. Thank you.